Good evening, everyone. Welcome to LinkedIn's first virtually hosted TechCon site engineering blog. Thank you to each one of you for taking time out to be a part of it. I'm Manisha Malik at LinkedIn. I'm part of Kafka SRE team, which is responsible for maintaining one of the largest Kafka ecosystems on the planet. During this session, we will share the work that is being done by SiteEng team in India at LinkedIn and the impact we are making globally. A quick note to the audience. We will be taking all the questions after the talks, and meanwhile, please feel free to drop your questions in the chat. If you have a specific question to be answered to a specific speaker, please mention their name as well. We will help moderate them. I would like to begin the session by introducing our first speaker, BG Sudhakar. BG is a site manager, senior manager at SRE organization at LinkedIn Bangalore. He joined LinkedIn 3+ years ago and leads our infrastructure SRE teams. He is passionate about the people, processes, and technology involved in engineering reliability into large-scale complex systems. Over to you, BG.
Thanks, Manisha. Hello, everybody. Good afternoon, firstly, and welcome to the site engineering track of TechCon 22. We have some very interesting talks lined up for you, as outlined by Manisha. Before we get into those, however, I want to take a few minutes to set some context by providing an overview of site engineering at LinkedIn. At a high level, site engineering is the umbrella org at LinkedIn, which is responsible for our data centers and production environment. We do network engineering, systems engineering, performance engineering, and site reliability engineering. Next slide, please. As a company, LinkedIn has experienced continuous growth since its early days. LinkedIn currently has around 810 million members as of early this year, and with around 115 million weekly active users. These members interact constantly with our platform. To provide an idea of the scale we operate at, we serve upwards of 1 million queries per second, send 17+ trillion Kafka messages a day, and have 2 exabytes of offline grid storage capacity. To deal with this kind of scale, we need cutting-edge technology and infrastructure platforms that work seamlessly, can scale to the demand of business growth, and that are easy to operate. This is where site engineering and site reliability engineering play a huge role. We apply engineering principles in order to make this complex infrastructure scalable, reliable, and easy to operate, so that every member of the engineering workforce at LinkedIn can easily manage LinkedIn's ecosystem. So the last 7 or 8 years have seen our growth trajectory get steeper. It took us about 10 years to reach 1.5 billion in revenues. But in the last 8 years or so, we were adding almost $1 billion in revenue every single year. While growth in the last few years has been huge, we expect it to continue to remain strong in the coming years. The next few years are going to be very interesting here at LinkedIn, where we will witness tremendous business growth and massive infrastructure growth to go along with it, creating opportunities for each of us to learn, grow, and most importantly, to create meaningful impact. Site engineering, specifically as a function, plays a very critical role in enabling LinkedIn's hypergrowth. Next slide, please. So at a high level, the site engineering organization consists of software, network, database, systems, and infrastructure engineers. We have teams distributed around the world in several locations. While we have globally distributed teams, we trust each other to do our best work wherever it works best for us and our teams. So in other words, hybrid/remote work is here to stay. Next slide, please. So just want to touch upon some of the principles we follow. Site up for us is foundational. It's quite simple if you think about it. If the site isn't up and functioning, we don't have a business. In addition, it takes a village to run complex production systems and infrastructure. Developers need to own operational problems as much as anyone else, and a tight feedback loop between software development and production operations is critical. So we build lots of self-service tools, platforms, and systems in order to enable this. Last but not the least, we think of operations like any other software engineering problem, requiring engineering work, not heroes and raw effort. So we conceptualize the SRE journey, as I like to call it, SRE evolution and maturity along a scale that involves progressing through multiple phases, starting with firefighter, gatekeeper, advocate, partner, and engineer. The effort for us is constantly to move towards the right. We've come a long way on this journey so far, but we have further to go yet. The future is exciting, and we're preparing ourselves to meet the challenges ahead. With that, I'll hand things back over to Manisha.
Thank you, BG. What a wonderful start. Thank you, BG, for taking us through LinkedIn's Cytops journey. Moving on, delivering a second talk, we have Saurav. Saurav is working as staff engineer with infrastructure performance and application SOG at LinkedIn. He likes things to be as automated and performant as possible. And with that aim, currently builds solutions that allow engineering teams to make sure their products can scale to millions and billions of users worldwide. Today, he will be talking about improving the debugging experience for engineers at LinkedIn. A very interesting topic indeed. Over to you, Saurav.
Thanks, Manisha. So, welcome everyone to the Tech Talks. And today we are going to talk a little bit about how we are trying to improve the debugging experience when it comes to analyzing, fixing applications that are serving millions of members worldwide, and how we are tackling the productivity drops that take place when teams are involved in fixing issues here at LinkedIn. Next slide, please. So as a part of this talk, we will be covering a couple of different topics, starting all the way from what is our current technical footprint looks like at LinkedIn. Then what happens when things start going southwards and issues start appearing. And last, we will take a look at how we are tackling this problem, making the debugging experiences easier and improving the engineering productivity when things don't work as they are expected to be. So as it is said, there has never been a short debugging period ever in the whole history of computers and engineering. So how do we make it easy, and how do we scale it up as the product scale? So let's start first from our technical footprint. Next slide, please. So LinkedIn on its own is a microservices architecture, which consists of 800 plus microservices all across LinkedIn. So when you load linkedin.com, it is not just one simple service which is going to load up your page, but rather a combination of 100 or 200 services working in conundrum with each other, powering you that page. All of these services expose more than 25,000 plus API endpoints, which interact with each other internally, externally, and serve you a one single final page, which you get to take a look at in your browser. And while you're visiting linkedin.com, all of these services are emitting number of different metrics related to how they are performing. How long did it take to respond? Was there any error while providing that response? And when we accumulate all of these metrics, they end up being equivalent to a couple of 4 trillion plus metrics being generated every single day, from which we need to find out if there is a problem and where that problem is coming from. Next slide, please. So when issues happen, they can happen at any point. They could be appearing at any place of development when code was written or merged, or they can appear anytime once that code went into production and when the user started using it. Next slide, please. In between all of these issues, one of the topmost priority is that the site remains up, because once the site goes down, it negatively impacts our members as well as also impacts our revenue. So making sure that the site remains up and functional, and making sure that our users are always at a priority is important. So what happens when an issue occurs? There are a couple of things that take place here inside LinkedIn. Every single service that powers our production site is continuously monitored, and its health is always established. As soon as there is a single drop in one of the metrics, maybe it could be the time for the service to respond, or it could be the number of errors that the service may be showing up. If anything goes off, alerts start getting raised, and these alerts are then routed to the development teams as well as the site reliability engineers who are partnering with those teams. And these teams form the first response teams. They take a look at what's going on, whether this alert is actually impacting our business or is it a misfire. And if there is an actual impact, they start looking at how they can fix it. Now, when it comes to fixing these issues, which these alerts are pointing at, the first and foremost thing is root causing. What is causing this alert to be fired? Is it one of the recent code changes that went into production and caused this problem? Or is it some other service which they depend upon, which is misfiring and causing this problem for our service? Let's try to simplify it. When you open the linkedin.com homepage, uh, and it is taking 20 seconds to respond, sometimes it could be that service which is rendering that page itself, or sometimes it could be some other isolated service somewhere down the line, maybe a database, which was actually responding slow and causing this page also to slow down. So root causing efforts involve first establishing the cause and figuring out whether it was caused due to a code change or a recent deployment or maybe some other problem. Once the root cause has been established, the next obvious step is to mitigate, because we want to make sure that the site remains up. And the mitigations generally involve either rolling back to the stable version or issuing immediate bug fix that helps stabilize the service. Once the hot fixes are deployed, the teams move into a retrospective mode and discoverability for a longer term fix, and also to make sure such issues do not appear again. Now, the challenges with hundreds of services interacting with each other to generate a single page, debugging can become exceedingly complex and time consuming. So how do we start tackling this challenge and make sure that the engineering teams can focus upon building stuff which matters and not have to spend extraneous amounts of time dealing with number of code changes, trying to figure out which deployment went wrong or which code change went wrong? Next slide, please. So how are we trying to improve the engineering productivity? With all of these challenges, 2 years back, we started envisioning a platform which will make debugging easier for our engineering teams. A platform which can combine all these millions and billions of metrics that get emitted every day, analyze them, build a trajectory from which, when there is a problem, our engineering team can come to this platform and navigate and narrow down upon where that problem is coming from and what might be causing that problem. Next slide, please. As a part of that effort, we built something known as a Service Performance Insights and Regression Analysis platform. This platform now powers a lot of different use cases inside LinkedIn. First and foremost being, every engineer has a complete visibility about what their service is doing and which all services they are interacting with, including and not limited to each and every single API endpoint. And when they take a look at it, they can not only see how they interact with each other, but they can also get to know how these services are performing. What is the response time this service is having? is there some jitter in that response time? And if there is a jitter, they can pinpoint to a single call that may be showing that response time. So out of hundreds and billions of calls that this service might be serving every day, an engineer is able to now pinpoint that one isolated call or take a sample of those calls which were showing 30 seconds to respond in comparison to the expected maybe 1 or 2 seconds it might have required. And this experience allows them to take a look at whether it is it their service which is coming out at the problem, or is it some other service which is causing these issues to come up. And this helps save them a lot of time. And we will cover up about that in the next few slides. This platform now serves as a single stop platform for starting to analyze any regressions related to performance or stability of the service. And it is being ramped up pretty quickly inside for all the teams. So how do we handle all of this thing? How does this platform works? So when we get all these events and metrics that are emitted by the services, we have our offline data pipelines, which are built on top of Hadoop and Spark, which process these metrics every day at hourly granularity. Because when we talk about these metrics, teams want these issues to be analyzed and data being available to them as fast as possible. So we start analyzing these metrics every hour. And from these analysis, we generate a couple of metrics which we think are important. Things like if there is a latency increase, like for example, if a service is taking too long to respond, whether there is a very high error rate, a service is failing continuously. And we also take a look at whether this service is having some A/B experiment, like some set of users are having a different experience while the other members are having a different experience. And if there is a significant degradation in one of those experiences. And based upon that, we provide our engineering teams with a report saying that what changed and what's the impact of that change. And with those set of informations, these teams can now pinpoint which service is getting impacted and whether it will cause a member impact, whether one of our members is gonna see linkedin.com as down, or whether they will not be able to use the functionality as they were expected to use. And that is what this platform powers. This platform has now been in production for a couple of quarters. And we have been taking a look at how the teams are taking it. And we found some couple of interesting things. Some of the teams discovered certain issues in their services which were not apparently clear earlier. And they were now able to narrow it down properly to whether it was happening because of the changes they made, or whether one of the systems that they generally depended upon started degrading over the last couple of weeks. The time to debug those issues has reduced. And the end result of all of this is these engineering teams are now being able to focus upon building new features rather than firefighting issues or spending their time focusing upon debugging issues. And with the new features coming up, it improves the experience of our members and helps us build experiences that matter. And with that, I will like to hand it back to Manish.
Thank you, Saurav. That was truly insightful. Moving on, delivering our next tech talk, we have Ankita Goel. Ankita is a senior Cytops operations engineer. She has been with LinkedIn for 8+ years. She has played an active role in almost all projects or tools that have been developed, such as CM Timeline, Cytops Dashboard, and different database projects. She is subject matter expert in LinkedIn growth. Joining her today is Seema Upadhyay, who is also a senior site operations engineer. She joined the team 2 years back. but has nevertheless contributed to some impactful projects like the Incident Management Heads Up tool. She has actively participated in various programs like LinkedIn School of SRE, LinkedIn Coaches, and many more. Ankita and Seema will cover Cytops and its growth at LinkedIn. Over to you, folks.
Thank you, Manisha. Good evening, everyone, and welcome to the session on Cytops and its growth. This session will be taken by my colleague Ankita and myself, Seema. Right. So in this session, we will be giving you an introduction into the Cytops team and who we are. Secondly, we will be discussing about our roles and responsibilities. Third, we will delve into some of the projects and tools that we have built and the impact it has had. And finally, we will be talking about our team's growth over the years.
All right, let's get into a scenario here. So let's say that LinkedIn.com homepage is not loading. Something has gone wrong. We have the LinkedIn.com homepage, SRE is looking into it, and then they contact the database team once they are done with their initial investigation. Meanwhile, we find out that the messages are not being sent out. And the messaging SRE contacts the database team because they find out that they have some database related errors too. Now, while these two issues were separately being investigated by the database team finds out that they have issues with multiple databases right now, and they try to resolve this ASAP. Now, what was wrong here? While there were 3 teams who were individually looking into issues, which although were related, the customers continue to see impact. So how can this be improved? Next slide, please. Yes. So first thing, have a common placeholder for all ongoing incidents so that any team who's having an issue can check if their issues are already being investigated. Mitigate an issue if the resolution and the root cause is going to take time because customers need to see minimum amount of impact. Communicate individual team statuses to other teams so that MTTR is fast. Get help from any team required as soon as possible. Communicate to stakeholders so that they are aware of what is happening and can answer questions by anyone. Now, who handles all of this at Cytops and more? Who handles all of this at LinkedIn and more? That is Cytops. So an ideal situation would have been where the LinkedIn.com page going down and the messages not being sent out was communicated to Cytops. Cytops then communicates with database team and the other 2 teams so that everything can be solved as fast as possible. Next slide, please. Now, at LinkedIn, Cytops is also called as the jack of all trades, and I will tell you why. Next slide, please. So Cytops is a central POC for all production-related issues at LinkedIn. We own the site as a whole, unlike SREs and devs who are owners of certain individual services. We are responsible for the initial troubleshooting and investigation of incident reports, and then we pass on our information to all of the SREs and the devs required at that point of time. We collaborate with different teams at different points of time. This collaboration could be for incident management, it could be for any changes that are going out, or it could be postmortems. Next slide, please.
All right. So what do we do? First, we monitor the availability and performance of the entire LinkedIn application stack using our homegrown tools. A lot of the important alerts are onboarded onto our dashboards. Second, we own the incident management process right from when the incident is reported until its resolution. Third, we are responsible for traffic management, deployment pauses, etc. We'll get into what traffic management is a little later on. Let me explain what deployment pauses are. So Cytops is the only team that has the permission to put a pause on the production environment to prevent any changes from going into the production environment. We require this especially when there is a major incident going on and we don't want to make any further changes to aggravate the incident anymore. Fourth, we drive daily site stability stand-up meetings. In these meetings, we discuss any major incident that has occurred in the past 24 hours. Also, any new changes that have to be made to the site, the production environment, has to be brought up in these stand-ups and they have to be approved by us. Fifth, we automate tasks and build tools. So we automate any tasks that are repetitive and also build tools that help us reduce our MTTR and MTTD. Sixth, investigate growth metrics. Growth is an indicator of the health of a particular company, and we measure metrics such as sessions, page views, etc. So Cytops reviews these reports, and in case of any anomalies, we investigate it and find out the reason behind these anomalies. Sixth, perform site load tests. So we as a team perform load tests regularly to ensure that LinkedIn is scalable and can handle the increased load in the foreseen future. Next slide, please. All right, so meet the team. This is our team. We're currently a 7-member team, and this is just the Bangalore team. We do have a sister team in the US. The Bangalore team maintains the site for 12 hours, and the US team maintains the site for the remaining 12 hours. Next slide, please. All right, little things, bigger impact. As we described previously, operations is something that is core to our job. However, we've given equal importance for automating manual processes and building tools in our day-to-day lives. Why is this necessary? Is because automation ensures that we make less mistakes. It ensures that the process is faster, and it also makes sure that the time that we spend on these manual tasks are reduced. Next slide, please. Right. So let us talk a bit about the tools and Slack bots that we have developed by taking an example of an incident. Say, for example, LinkedIn profiles is not loading. Like when you click on your profile, it is showing up a blank page. As described previously, when an incident of such a magnitude occurs, it is required that the incident is reported to the Cytops team. Now, when we start our investigation, we collect all the details required, such as start time, end time, etc. And one of the most important detail is the impact. We need to know the extent of the incident. What I mean by that is, are all members of LinkedIn affected by it, or only a subset of members are affected by it, or is it just the internal employees affected by the issue? So once we have this, first, what we do is check if there are any ongoing incidents that could have resulted in this impact. For this, we have a dashboard that shows the current running incident with all the important details. Next slide, please. So this is the incident dashboard. We have incidents daily, which is the incidents that have occurred for the day, and incidents still open, which are the incidents that are still open. In each of these, we have the ticket, the summary regarding the incident, the status of the incident, the severity, start time, labels, and the impacted teams. Now, based on the information in this dashboard, we can figure out if the impact of the reported incident could be related to any of these incidents. Next slide, please. All right. So another important responsibility of Cytops team is to make sure that we mitigate the incident as soon as possible. Now, say, for example, the impact of this LinkedIn profiles incident was confined to only one particular data center. What I mean by, so in LinkedIn, we serve traffic from 3 different data centers. And if say the issue is confined to just one particular data center, then we can afford to fail out traffic from that particular data center to ensure that it is mitigated. What do I mean by fail out? Basically, we redirect the traffic such that the traffic goes to the other 2 data centers and not the problematic data center. However, we need to ensure that this is possible. Next slide, please. What I mean by it being possible is, say, for example, prod 1, prod 2, prod 3 are our data centers. The color green indicates that all of them are up and running. Now, say, for example, there was an incident 1 due to which prod 1 was failed out, and an incident 2 due to which prod 2 was failed out. And say this profiles incident was in data center 3. Prod 3. In that case, we cannot fail out prod 3 as well, because if we do, it means that the entire site will be down. So this dashboard helps us see what data centers are online and if we can afford a fail out or not. Parts 1 to 4 at the bottom table indicate different types of traffic, like member traffic, guest traffic. And the traffic column with the numbers such as 30,000, 60,000 are queries per second. Next slide, please. All right. There is another reason why this impact could have occurred. It could be because of an ongoing change that is currently happening. Now, in order to find these changes, we have another dashboard created, which shows us the ongoing changes. Next slide, please. So this is the change timeline dashboard where, as you can see, we can find the change, we can see the start time, end time, and we can also see the user that is conducting the change. So in case this impact is an offspring of this particular change, we can always go back to the user and ask them if this impact is due to their change and figure out why this impact is even occurring. This is the same dashboard that is used in the stand-ups to discuss any new incoming change that has to go into the production environment. Please note, all the 3 slides that previously screenshots that we showed are dummy data just used for this particular presentation. Next slide, please. All right, before we move on to Slackbots, I'd just like to cover the remaining tools. So we do have tools that have automated the communication to various stakeholders when required. This is in case of like major or medium incidents. It is mandatory that we inform the stakeholders. Then we have a service to DB mapping for easy troubleshooting. So we as Cytops members also can track the services and find out the DB that is behind these services. And finally, we also have a one-stop shop for Cytops for all the team-related information like documents, tools, etc. Moving on. We understand that during investigating an incident, it is very difficult to open multiple dashboards and to see what exactly each one of them are saying. So in order to make things easier, we have corresponding Slack bots. Right. So I've just taken an example of the bots corresponding to the dashboards I just showed. So change details, bot change -details gives us the current running change, the title, the status, and the assignee, and any other information. Bot traffic status gives us the failout status. From this example, we can see that prod 1 is failed out for incident 1 on 29th March. And thirdly, we have incident details, which is bot incident info. This gives us a brief description of the incident, the priority, and the start and the end time. Next slide, please.
All right. Cytops has grown exceptionally over the years with respect to what we monitor and how we monitor. I'll take you through some of the befores and afters of these. So from handling both low priority and high priority alerts to only handling high priority alerts. So we have moved from handling single host related alerts, service related alerts, which may or may not have had a big impact, to only handling high priority alerts. An example of this would be the profile issue. We would get alerted for high profile related alerts. From manual to automated heads up. We keep our higher ups informed of any major incident so that they know what is happening and they can answer any questions that are thrown at them. This was something that required a lot of manual phone calls before, but now it is automated with just one composition of a message. Next, command line tools to one-click solutions. As Seema mentioned, we try to mitigate an issue via traffic failout. We may have to see the list of services that are impacted. We may have to check for various logs and stuff like that. This previously was handled using command line, but now we have various GUIs and one-click solutions to these. And then deciding the issue priority via experience versus fixed guidelines. So we used to decide issue priorities based on an SRE's and a Cytops engineer's experience. This has now been taken care of by certain set of guidelines that we have, which helps us reduce the need for investing time into decision making. Fetching details regarding an incident to just reviewing details and logging them out. So when you have major incidents going on, we would like to log them. And when you have SREs looking into things, it is difficult to get those details from them. So we now have a form where the SREs enter their details, Cytops reviews those details and logs them out. So all in all, Cytops continuously enhances and looks into its procedures and tools so that LinkedIn.com's MTTR and MTTD related issues can always be at best. Okay, I'll passing it on to Manisha again.
Thank you, Ankita and Seema, for such an informative presentation. And now Finally, it's time to feed our curiosity. I am delighted to hand over the floor to Priyanka Yadav, who is working in infrastructure monitoring and visibility space for the Q&A session.
Hey, thanks, Manisha. So let's start with asking our speakers some questions based on their tech talks. So first, we have a question from Shashikala for Saurabh. The question is that since there are multiple calls and traffic flowing within the network, and since microservices are also integrated, how is scalability managed at LinkedIn?
Thanks for the question. And yeah, let me try to answer it. So there are a couple of different perspectives from which we can answer scalability. So I will try to answer how we currently manage our scalability for LinkedIn.com and all the different set of microservices that power LinkedIn.com. So one of the parts is when teams are developing these services, one of the core development aspects is also scalability and scale testing, and also like pre-planning for the capacity in terms of what kind of traffic this service is going to deal with most of the time. So here is how we generally deal with the scalability aspects. First and foremost is for a new service that is being launched into production. The services are generally launched in a stepwise manner. They will initially be like ramped up for only a small set of population, member population of LinkedIn. And the traffic will be analyzed, and the services scalability is also analyzed at that scale. And this is what I'm talking about production traffic. We do have certain steps which we take beforehand, like synthetic load testing and those aspects, to also understand what kind of capacity requirements will be there and how many parallel instances need to be provisioned, what kind of database allocations we require. And once that synthetic testing is done, and then the service is ramped up to a small subset of users, maybe like 1%, 2%, stability is monitored. And gradually this ramp is increased from maybe 1%, it will be ramped to 5% or 10%. And gradually this will be rolled out all the way till 100% if no issues are seen during the testing. Now, once this service has been established and new features are being added, or the user base is growing, our deployment platforms also inculcate certain regression checks. Like when a new service is ramped up, the service will be monitored for its health for maybe a couple of hours before it is fully rolled out into production. That's the second state which is done. And while in production, we also have continuous monitoring of these services, like traffic queries coming up per second, and what kind of response time the service is showing. And the owner of the service will generally get a heads up alert saying that, hey, maybe your service is reaching the maximum threshold of its capacity pretty soon. So you might want to scale it up further. So this is how we deal with scalability. In 95% of the cases, all these aspects work fine. For the remaining 5%, we might have to take a look in a retrospective manner also and scale the service as it need arises. Those are more of like once in a blue moon cases rather than things which appear every day. So these are some of the systems which we have in place to make sure the services remain scalable and we are able to scale them up ahead of time rather than responding only after failures and users seeing outages. I hope that answers the query there.
Yeah, thank you so much, Saurabh, for answering that. So next question we have for Ankita and Seema. So what technologies are used in projects by the Cytops team?
I think I'll take that one. So it actually kind of depends on the projects that we are developing, but generally we develop it in Python. When it comes to web apps, we use Flask, and obviously for front end HTML and CSS. But I would say that we do have the freedom to choose our technologies based on what kind of solution we are coming up with. Thank you.
Thank you for answering that, Seema. We have one more question from Umang. So Umang is asking, do service owners take up the ownership directly, or the Cytops or SRE are the first people to get altered? And are the tooling around real-time monitoring using industry standard tools or custom solutions?
Okay, I'll take that. Some alerts, the SRE would get pinged directly, and some alerts, it would be via Cytops. They would also get pinged for it. Cytops would get pinged for alerts when the impact is very high. An example would be profile not loading for 50% of the customers. We would get such level of alerts. With respect to alert monitoring, our tools are internally built. They're not from outside. Yeah.
Okay, thank you, Ankita, for answering that. So next question we have is that, do we use Kubernetes as well?
I can take that question. So we have a transition path to towards Kubernetes we today in the production environment do use Kubernetes, not for all workloads. So we have specific workloads that are on Kubernetes, and then the majority of them are on a platform internally built. And just want to call out also that we're moving LinkedIn as a company is moving all of our infrastructure to Azure over the next few years, and we're going to be adopting AKS in Azure as part of that transition as well. So we have teams working on it. We have workloads that run on Kubernetes, and we're pivoting more towards that direction as we get into a cloud journey.
Thank you, BC, for answering that, and thank you, Supi, for asking the question. Next question we have for Saurav. And the question is that, how do you diagnose a problematic service based on the metrics? Do we use some machine learning algorithm to point out the problematic node?
So yeah, on that note, it's generally a hybrid. So one of the parts of debugging any problematic services, it requires context. What changed? Sometimes it could be a recent code change which was deployed into production, while the other times it could be one of the downstream services. For example, let's say your service connects to a database, and that database itself is performing slow and not able to respond to the queries as it used to be. So in that case, also your services might start seeing regressions, or maybe it can end up seeing failures at the same time. So the best effort base, any algorithm that works is basically best effort basis. We correlate the metrics. We try to see, let's say there was a latency increase. Now, while this latency increase is taking place, there are a number of other metrics also which are being emitted by the service. It could be related to maybe how much memory the service is using. The other metric could be, was there any active garbage collection that was happening during that time? Now, if the latency increase coincides with this increase in garbage collection activity, we can potentially start pinpointing the user, saying that, hey, you should possibly drill down on this path. It's not one of your downstreams, but rather this is your own service, which is showing higher memory allocation or maybe garbage collection. And this is the path which you should focus at. So at this particular point of time, what we are doing is we are not able to exactly pinpoint 100% of the time what is the cause, but rather guide the user in a direction where they will be able to find out the cause in a much better manner than just wandering in a wild forest of hundreds of metrics that may be emitted. So all in all, it's not just a pure machine learning algorithm. It's a hybrid of machine analysis plus user context based search.
All right. Thank you, Saurav. Next question we have for Cytops. The question is that, does the team work on weekends as well, since Cytops covers 24/7?
Yes, we work on the weekends as well. Every Cytops engineer in a month will do weekend shifts, which will either be a Saturday or a Sunday.
Okay, Thanks, Ankita, for answering that. Next question we have from Yakravrit. And the question is that for Saurabh, do you log all the requests or use percentage-based logging? Asking in light of figuring out high response time request.
Yeah, so this is actually an interesting question when it comes to do we log everything or not? So the answer is no, we do not log everything. The amount of data, if we log everything, is gonna be way too tremendous for us to manage our process. So what we do is first, only a subset of requests are traced in terms of on the metrics. And when I say traced, I just want to also clarify in the first place that when we talk about tracing, we talk about metrics like performance and all, and not the user data that is being generated. So none of the user data actually gets logged or traced in this aspect. In terms of metrics, maybe if let's say LinkedIn receives 1 billion requests in a day, we only trace like maybe 20% of them. From that, our offline pipeline select interesting samples. And when I talk about interesting, it means certain samples which were behaving normal are selected. Then certain samples based upon different flavors are selected, like high latency, having different error codes, HTTP error code, like let's say 500, 400, and certain response code as 200, which are expected to be okay. And then we also select certain samples which show something like, let's say out of 100, it was expected that most of these samples will call only 20 downstreams, but out of them, 5 are calling maybe 200. So those samples are also selected out of them. So we do further intelligent filtering on top of that, so that the users, the engineers inside LinkedIn get data which is relevant to them, and not like get bombarded with the all the different set of metrics and just have noise scattered around and not being able to diagnose anything. So yeah, there is some set of intelligent filtering on top of what we collect. And the final view that the engineer gets is a very much filtered view, which is specific and targeted to what they are looking for. Hope that answers it.
Thanks for explaining, Saurabh. I hope, Yakravrit, you got your answer. Next question we have from Umang. The question is that are most of the services containerized, or do bare metal deployments exist? Also, how are the releases for the services managed for both of them?
I can try to take it up to some extent. So in terms of containerized, yes, we have containerized services already. Although we do not use Kubernetes, but LinkedIn has been containers for quite a long time, and services are indeed containerized. Yes, we do have bare metal deployments also for certain services, like let's say certain database services. We have our own internal blob stores and all, which requires a full host to be allocated to them. And when I say full host, it means multiple full hosts allocated to them. And those services generally do not require any containerization and go for bare metal deployments. Depending upon, now talking about the deployment schedules and rollouts, it depends from service to services. For some of the services, we do like thrice a day deployment also. For some other services, they can see a deployment in maybe a couple of days, depending upon team cycle. This comes at also with the part of microservices based deployments, that teams choose to define their own schedules of deployments when there is no new feature release by to go ahead with the deployment. And when they want to push a urgent fix, they are independently able to push a urgent fix on their own. They do generally partner with their own site reliability partners to make sure that things remain stable. But cadence depends from team to team. So the answer will be, for some teams, it will be thrice a day. For other teams, it will be only once a day also. Hope that provides some clarity on our deployments.
Sure, Saurabh. Also, I guess we have one more question in continuation of your last answer. This question is from Dhanya. So the question is, how do you use Splunk for logging? And if you do, how do you scale the Splunk logging for so many customers?
Interesting question on that note. So our logging solutions are built in-house. Part of the reason is the frameworks which are used to build the production services have been developed in-house. And LinkedIn required a certain set of customizations to emit some metrics which are interesting to LinkedIn. Also to make sure they scale well for our needs. And these solutions were developed not just recently, but a couple of years back. And we have been continuing on those solutions. So these solutions for logging and every metrics are built in-house right now. And they are scaled independently on that basis.
I'll also add that, again, Azure to the rescue here. So we're, beginning to use Kusto a lot, for our logging, reporting, and analytics use cases.
Correct.
All right. Thank you, Saurabh. Thank you, BG, Ankita, and Seema for answering all your questions. Back to you, Manisha.
Okay, before moving on, I have a small suggestion for the audience to go and check out the site engineering booth before Rock Your Profile session starts next. So I would also like to request the audience to please share your feedback for the event with us by filling out the feedback survey by scanning the QR code on the screen. Feel free to fill in the feedback after attending all the talks of your choice. This will help us make the next such events we host even bigger and better.